This video, we are still focusing on linear review, but we're going to be identifying the slope and y-intercept, then graph. These two examples, one of them we have an equation, one of them we have a set of coordinates. When we have an equation, we follow the linear equation of y equals mx plus b. For slope, since we're finding the slope and y-intercept, the slope is the m value. It's what's attached to that independent variable of x. So therefore, the b value will be our y-intercept. We have to make sure we include whatever the sign is of that b value for our y-intercept. If we look at the equation we're given, this is in the y equals format. Therefore, this is already in slope-intercept form. Please understand that slope-intercept form does not have to be written in this order, but you do need to know which value is your slope and your y-intercept. The slope is attached to the x, so if we find the x, our slope goes along with that -2. So I'm going to put that the slope is that -2. Now we can write this as a fraction so we can figure out what our rise over run is. -2 as a fraction would be written as -2 over 1. Next is our y-intercept. Our y-intercept is the value that is by itself. It has no variable attached to it. So as you can see, we have a +3 at the end here. So our y-intercept is going to be at that +3. But if you remember, y-intercepts are written as coordinates. It's when your independent variable of x is 0. So our coordinate will be 0, comma, and then our y-intercept of +3. This is our slope and our y-intercept. So now we want to graph this. On our graph, you should always label your x and y axis so that you know which direction your graph is going in. So our positive x-axis is on the right-hand side, and our positive y-axis is on the top. We also need to know what we're counting by, so if we have to count by more than just ones to make our graph fit on our graph, then we need to label that. But since we have 0, 3 as our y-intercept, and we have a slope of -2, we can just count by ones. Count by ones. I'm going to put a CB1. So we go to our first coordinate. Our y-intercept is always your starting coordinate. So we go to 0, 3. So the 0 of the x's is here, and then we have to go to that +3 on the y. So 1, 2, 3. We're going to put a coordinate here, a little point here, and then we're going to use our slope to graph the next coordinates. Again, this is rise over run, so this is telling us to rise a -2. That means from this coordinate, we're actually going to go down 2, but then we're going to run a +1, because this negative can only go on one of these. So if we put it on the top, that's why we're going down 2. So we're going to go down 2, but then right 1. So down 2, and then right 1. We're going to do this as much as we can to make this as accurate as possible. So we're going to go down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Now I also have coordinates that I could potentially put over on this side because we know we're going to be drawing a line. So if the negative is on top for the first way, we can then change this to be a +2 on top and then a -1 on the bottom, because that still gives us that negative slope. So if we make this a +2 on top, we'd rise positive, so we'd go up 2. But then we'd have that -1 on the bottom. That means we'd have to run left 1. So up 2, left 1, up 2, left 1. And these coordinates are still in the shape of a line. So now that we have our coordinates as much as possible, we can then graph and connect our coordinates by drawing that line. Lines have arrows on the end because they go on forever in the direction that they're going. So this is our slope and y-intercept of our first one, and it is graphed in slope-intercept form. The second example, we're given coordinates. Now we can graph these coordinates and then find the slope and the y-intercept, or we can find the slope and y-intercept first and then graph them. I want to find the slope first just so that I can write it out. So again, just as in the previous video, I want to find the change in x's and the change in y's. So my changes in x are +1, +1, +1, and +1. So as long as my changes in y's are the same throughout, because my changes in x's are the same throughout, then I know this is linear. So for my y's, we can from -4 to -2.5 is actually adding 1.5. From -2.5 to -1 is also adding 1.5. -1 to half is adding 1.5. And then from a half to a 2 is adding 1.5. So our change in y is a positive 1.5 over our change in x is a positive 1, which is 1.5. This is linear, so our slope is 1.5. However, you never want to actually write your slope as a decimal because slope we know as rise over run. We want it as a fraction. So this is 1.5. As a fraction, this would be 3/2. So our slope is a positive 3 over a positive 2. Then we want to find our y-intercept. Since we're given coordinates, we actually want to look to see, is it possible to find our y-intercept already? The y-intercept is always a 0, a number. So if we go to our x's, we have a 0 already. That tells us that this has to be our y-intercept. So our y-intercept is at 0, -4. Now we can graph. First coordinate, we want to put our x's and y on our axes, so a positive x-axis and a positive y-axis. Then I'm going to put our count by, since we're at 0, -4, and we're going up, rise and overrun as 3/2, we can probably just count by 1. So I'm going to put CB1. So 0, -4, x of 0, y of -4. 1, 2, 3, 4. Put in a point here. And then our slope is 3/2. This is a positive 3 and a positive 2. So this is going to be a rise of positive 3. That means up 3. And then a run of positive 2, which means to the right 2. 1, 2. I'm going to do that again. So rise positive 3. 1, 2, 3. Run 2. Up 3. Right 2. This is as far as I can go up and to the right. But let's see if we can go in the opposite direction from our y-intercept. So in order for this to be a positive divided by a positive is a positive slope. But also a negative divided by a negative is a positive slope as well. So I can change this to a -3 and a -2. So I can go down 3, 1, 2, 3, and then left 2, 1, 2. And as you can see, this is still in the shape of a line. Now that we have as many coordinates as possible, we can connect them and put our arrows on the end. Now we had a coordinate of 2, -1. If I go to 2, -1, it is also there. 3.5 for your y, so if I go to 3, it should be around that 1/2. And sometimes when you're drawing, if you don't have a ruler, it can get slightly off. But that's why you always want to look for the coordinates that are in the corners of the graph. So right here at 4, 2, this is easily discernible of 4, 2 because it's on that corner. So this is our slope and y-intercept, and we have graphed this problem.